Okay, dear student, now I am discussed about the interference of light. Listen, what's an interference of light? It is the phenomenon of redistribution of light energy due to the superposition of two or more light waves. What is an interference of light? It is the phenomenon of redistribution of light energy. Redistribution of light energy due to the superposition of two or more light waves. Is called interference of light. Interference of light, or distribution of intensity in the region of superposition of two or more light waves, or distribution of light energy in the region of superposition of two or more light waves is called interference of light. Why the cause of interference of light? Because of the two light waves are traveled in the same directions. The crest of the one wave falls on the crest of the other wave, or trough of the one wave falls on the trough of the other wave, that produces the maximum intensity at that region. Next point, the crest of the one wave falls on the trough of the other wave, that produces zero intensity at that point. The interference pattern consisting of alternative dark and bright fringes. The bright fringes are produced at the point the crest of the one wave falls on the crest of the other wave. The dark fringe is produced at the point crest of the one wave falls on the trough of the another wave, when two light waves are traveled in the same directions. Theory of interference was first discovered by Thomas Young. The example for interference pattern: the color pattern observed on the road when oil spill on the wet road, or large radius of curvature of the convex lens is placed on the glass plate and it is illuminated by monochromatic light. Alternative concentric dark and bright fringes are observed. This is the due to interference of light. Similarly, wedge-shaped air film is placed on the glass plate. When it is illuminated by monochromatic light, that produces alternative dark and bright fringes due to interference of light. Interference of light is produced due to two light waves are traveled in the same directions when the crest of the one wave falls on the crest of the other waves, produces maximum bright fringe at that region. Similarly, crest of the one wave falls on the trough of the another wave, that produces dark fringe at that point. Where the condition for well sustained interference. Condition for well sustained interference. First condition, two sources of light must be, the phase difference between two light waves is constant. Phase difference between two light waves is constant. What is a phase difference? It is the phase of the vibrating particles. It is the difference in the phase of the two vibrating particles. It is called phase difference. For example, when two light waves are reached at point P, this is one light waves. This is another light wave. The phase of vibrating these two particles. Phase means both position and direction of the particles at any given instant of time is there in a state of vibrations. For example, the phase of the particles at zero phase at the first wave, the phase of the particles at 180 degree at the second waves. the phase difference is constantly maintained to reach point P. This is the phase difference between the two light waves is constant. It is 180 degree. Next, the two light waves are come from same source of light. Two light waves from same source of light. Next conditions, two light waves having same wavelength. Light waves having same wavelength. Next conditions, same amplitude. Two light waves having same amplitude. Same amplitude. This amplitude, it is the maximum displacement of the particles in their mean position is same. The phase difference between the two light waves is constant or zero phase difference. The two light waves from the same source come from same source of light. Two light waves having same wavelength and same amplitude. These are the conditions for well sustained interference. Next concept. Phase difference and path difference between the two light waves. Phase difference and path difference. First, I am discussed about phase difference. Phase difference. It is denoted by phi. What is phase difference? It is the difference in the phase of two vibrating particles to reach a given point. It is the difference in the phase of two vibrating particles. Vibrating particles to reach a given point. To reach a given point. The difference in the phase of two vibrating particles. Where is the phase of two vibrating particles of the light? Where, for example, it is the given point P. This light wave, first light wave and second light waves. This is the waves traveled in these directions. This is the phase of the vibrating particles to reach a given point P. This is called phase difference. Now it is written phase difference, where phase difference is equal to 2 pi by lambda times. This is the path difference. 2 pi by lambda times path difference. Or it is a phase difference is equal to phi is equal to 2 pi by lambda times delta be the path difference. Delta be the path difference. Next, what is a path difference? Path difference is delta. It is the difference in the path traveled by the two light waves to reach a given point. It is the difference in path traveled by the two light waves. Path traveled by two light waves to reach a given point. It's called path difference, where path difference is equal to lambda by 2 pi into its phase difference. Expression for path difference. And the difference in the path traveled by the two light waves in a given point. For example, this is the path of first light waves. This is the path difference. Path difference between two light waves. This is the path difference between two light waves, 0 to x. This is the path difference. Next, coherent sources. What are coherent sources? What are coherent sources? The two sources of light having zero or constant phase difference are called coherent sources. Two sources of light having zero or constant phase difference. Constant phase difference are called coherent source. What are the examples for coherent sources? The two emergent light waves from the point source or two pinholes. The light waves are emergent from two pinholes or equidistant from the source or coherent. Or two cylindrical wavefront from equidistant source or coherent sources. Two cylindrical wavefronts emerges from equidistant source are called coherent sources. Or two spherical wavefront emerges from equidistant source are called coherent sources. The difference in the path difference or phase difference is constant or zero phase difference between two emergent light waves are called coherent sources. Example for coherent source means the two spherical wavefront emerges from the spherical surface from the equidistant source, or two cylindrical wavefront emerges from cylindrical surface of equidistant source are called coherent sources. The condition for well-sustained interference, the two sources of light must be coherent. They produces alternative dark and bright fringes on the screen. Next concept, a theory of interference. Explain the theory of interference of light. Theory of interference of light. We consider two sources of light, S1 and S2 be the two sources of light. S1 and S2 be the two sources of light to reach a point P. They produces interference pattern at point P. How it is explained? Where Y1 be the displacement of light waves. Light wave S1 is Y1 is equal to A cos omega t. Y2 be the displacement of light wave S2 according to the principle of superposition. What is the principle of superposition? The vector sum of the individual displacement of two light waves must be equals to the resultant of these two waves. Resultant displacement must be equal to vector sum of the individual displacement. For example, y is equal to sum of displacement y1 plus y2. y1 andre it is the resultant displacement of two light waves to reach a point P must be equal to sum of the individual displacement of two light waves. It is the y1 plus y2. Here y2 is equal to, we take a cos of omega t minus pi. The resultant displacement according to the principle of superposition must be equal to y1 plus y2. We take equation 1. Take equation 1. Put y1 and y2 value in equation 1. Put y1 and y2 value in equation 1 and apply off angle formula, where y is equal to a cos omega t plus a cos of omega t minus pi. If pi be the phase difference between two light waves, we take a is taken the common, cos of omega t plus cos of omega t minus pi. Here apply off angle formula, where cos a plus cos b is equal to 2 of cos of a plus b by 2 into cos of a minus b by 2. Apply this formula for above equations. Get it? Well, y is equal to a into 2 cos of, this is a, this is b, omega t plus of omega t minus pi by 2. Where cos of omega t minus omega t minus pi by 2. Where y is equal to a into bracket 2 of cos omega t minus pi by 2 into cos of minus pi by 2. Cos of negative angle we take negative. Next, where y is equal to 2a into cos of omega t minus pi by 2 into cos of pi by 2. Where we take, this is the resultant displacement of two waves. Resultant displacement of two waves. This is the resultant displacement of two waves. Next, what is the resultant amplitude of these two waves is given by resultant amplitude of S1 and the S2 is R is equal to 2a of cos pi by 2. Where resultant displacement is equal to R of cos omega t minus pi by 2. This is the resultant displacement, where R be the resultant amplitude. Resultant amplitude of two light waves. Resultant amplitude of two light waves. Where resultant amplitude is maximum at pi by 2 is equal to 0 degree or 180 degree. This is the expression for resultant amplitude and resultant displacement of two light waves. Next, write the condition for constructive and destructive interference. Next, condition for constructive and destructive interference. Constructive and destructive interference. What is the condition for constructive interference means? First condition is cos of pi by 2 is equal to plus or minus 1. Means resultant amplitude or must be equals to plus or minus 2a. Resultant amplitude or must be equals to plus or minus 2a. At what angles the resultant amplitude of the two waves must be maximum? To take pi by 2 is equal to 0, comma pi by 2. Sorry, pi, comma 2 pi, comma 3 pi, comma 4 pi, where pi is equal to 0. It is the maximum amplitude reason. Cos pi. Where next the phase difference is 2 pi, 4 pi, 6 pi, 8 pi. It means the phase difference between the two light wave is even number multiple of 2 pi. Phase difference between the two light wave is even number multiple of 2 pi. This is the condition for constructive interference. What is the phase difference between the two light wave is even number multiple of pi. This is the condition for constructive interference. Sorry, even number multiple of pi. What is the condition for path difference? Path difference between the two light waves. Delta is equal to lambda by 2 pi into phase difference. What is phase difference? Lambda is equal to 2 pi pi into 2n pi. Where 2 get cancelled, pi get cancelled. It is the delta is equal to even number multiple of lambda by 2. Even number multiple of lambda by 2. What is the condition for constructive interference? First condition is the phase difference is even number multiple of pi and the path difference is even number multiple of lambda by 2. This is the condition for constructive interference. Means the formation of bright fringe at that point. What is the condition for constructive interference? Means the phase difference between the two light waves. First condition, phase difference between two light wave is even number multiple of pi and path difference between two light wave. Path difference between two light waves is even number multiple of lambda by 2. Multiple of lambda by 2. Even number multiple of pi, even number multiple of lambda by 2. Next conditions, the resultant amplitude of the two waves must be resultant amplitude or must be equals to 2a at maximum intensity region. 2a. The intensity is directly proportional to square of the amplitude. The intensity of two light waves, the constructive interference, intensity of light waves in the region of superposition, I is proportional to r square, means I is proportional to 4a square at that point, or I equals to 4a square. The maximum intensity region is observed in the during constructive interference of light. The maximum intensity in the region of superposition of two light waves during the constructive interference is I is equal to 4a square. Okay. Next, what are the conditions for destructive interference? Next, I will discuss about destructive interference. Destructive interference. What are the conditions for destructive interference? The first condition in destructive interference, cos pi by 2 must be equals to 0. What is the cos? When the cos pi by 2 must be equal to 0, the phase difference between the two light waves is pi by 2, 3 pi by 2, 5 pi by 2, or the point of 7 pi by 2. This means the phase difference between two light waves, phase difference between two light wave is odd multiple of, means phase difference between the two light waves is odd number multiple of pi by 2. In the case of destructive interference, the phase difference between the two light waves is odd number multiple of this pi by 2. What is the path difference at that point? The path difference is equal to lambda by 2 pi into phase difference is equal to lambda by 2 pi into 2n plus 1 pi by 2. Since pi get cancelled. Sorry, this is the 2n plus pi. 2 get cancelled. Sorry. This case pi is equal to 3n plus pi, odd number multiple of pi. The path difference is odd number multiple of lambda by 2 pi into 2n plus 1 pi by 2, means pi get cancelled. It is 2n plus 1 into lambda by 2. Sorry, it is the odd number multiple of lambda by 2, odd number multiple of pi. Phase difference is odd number multiple of pi. Path difference is odd number multiple of lambda by 2 during the destructive interference. What it indicates? In the destructive interference, phase difference between two light waves. Phase difference between two light waves is odd number multiple of pi, and odd difference is odd number multiple of lambda by 2. Odd number multiple of lambda by 2. This is the condition for destructive interference. Means dark fringe region of the interference pattern. Dark fringe region of the interference patterns. The maximum intensity in the region of destructive interference. The maximum amplitude or resultant amplitude of two waves in destructive interference or is equal to 0. The maximum intensity at that point is also 0. Maximum intensity I becoming 0 at that point. Means because of I is proportional to R square. R is 0, I is 0. Means that produces dark fringe at that point. Produces dark fringe at that point. According to the theory of interference pattern when superposition of two or more light waves, redistribution of light energy in the region of superposition of two or more light waves, that produces alternative dark and bright fringes. All the width of the dark and bright fringes are equal width. The difference between the two alternative dark fringes and difference between the two alternative bright fringes are equal due to the superposition of two or more light waves. Condition for constructive and destructive interference is over. Next, Young's double slit experiment.